So this problem asks, if I have 2.9 moles of hydrogen and 1.6 moles of oxygen reacting, how many moles of water are produced? And this problem has two values given, but it doesn't say the words percent yield in it. So we need to know that this is a limiting reactant problem. We should also notice that 2.9 moles of H2 and 1.6 moles of O2 are both reactants. So we need to figure out which one of these is in excess. Remember in all those other problems it would say in with excess of blank, which one we have more than enough of and which one matters. First thing we have to do is make sure our equation is balanced. We have 4 hydrogen and 4 and 2 oxygen and 2. And the way we're going to solve this is we're going to see how much hydrogen we're going to see how much water I can make with this much hydrogen and how much water I can make with this much. Whichever one makes the least is the one that runs out first. So we're going to need mole ratios to go from moles of hydrogen to moles of water and moles of oxygen to moles of water. So from our balanced equation, we know that for every 2 moles of hydrogen that react, we can make 2 moles of water, and for every 1 mole of oxygen that reacts, we can make 2 moles of water. And these are just simple mole ratio problems. So we have 2.9 moles of H2. If we want moles of H2 to cancel out, we have to put moles on the bottom. And our equation here says 2 and 2 moles of water. So even though these numbers are both 2, it's basically a 1-to-1 ratio. Because times 2 and divided by 2, we're going to make 2.9 moles of water. Let's see how much water we can make with our oxygen. We have 1.6 moles of oxygen. We want moles to cancel out. We'll put moles of oxygen on the bottom. And 2 moles of H2O. So 1.6 times 2 is 3.2 moles of H2O. So we are out of hydrogen after we make 2.9 moles of H2O. Are we ever going to make 3.2? No, because we run out of hydrogen at 2.9. A lot of people will assume when they look at a problem that the limiting reactant is the one with the least number of moles. But look, we had less moles of oxygen, but it was our excess. It was the one we had more than enough of. You have to use your mole ratio in order to find out how much they can make, in order to see those relationships. So in this problem, we have 39.7 moles of aluminum and 28.9 moles of chlorine. So we need our mole ratios for aluminum to aluminum chloride and from chloride to aluminum chloride. So we know for every 2 moles of aluminum that react, we make 2 moles of aluminum chloride. And for every 3 moles of chlorine that react, we make 2 moles of aluminum chloride. So let's look at how much we can make with each of our amounts here. We have 39.7 moles of aluminum, and we want to convert that to moles of aluminum chloride. So moles of aluminum have to go on the bottom. 2 moles of aluminum to 2 moles of aluminum chloride. So if we times 2 and divide it by 2, we see it's 39.7 moles of aluminum chloride. So we have enough aluminum to make 39.7 moles of aluminum chloride. Let's see how much chlorine we have. So we're going to put 3 moles of chlorine on the bottom and 2 moles of aluminum chloride on top. Moles of chlorine cancel out. We do times 2 divided by 3, and we have enough chlorine to make 9. We have enough chlorine to make 19.3, we're sticking with our 3 significant figures, moles of aluminum chloride. So how much will we actually make? We'll make the smaller amount. We can't make 39.7 because our chlorine ran out after we made 19.3 moles.